Okay, so this last problem in this section is going to throw us a little bit of a curveball here. We're going to actually have a couple of parts to this problem, and we need to be able to sort of figure out how we're going to deal with that. And so what I want to be able to do is use my knowledge to and my strategy to help us figure out how to solve two-part problems or even three-part problems as follows. Okay, so the problem states a car travels at a constant 50 kilometers per hour for 100 kilometers. It then speeds up to 100 kilometers per hour and is driven another 100 kilometers. What is the car's average speed for the 200 kilometer trip? Okay, so we have two parts to this, and we're asked to find the average speed. And we're going to start this one out just a little bit differently because we've got two parts. We need to come up with something that will tell us how to solve this problem by dealing with both of the parts at the same time. And again, we've been asked to find the car's average speed for the trip, and we know that speed, and we're going to substitute in velocity here because we just want to not mix the two formulas up too much, but we want to know what the average velocity or the average speed is for, and I'm going to say V for the whole trip equals the distance that we go in the first part of the trip plus the distance that we go in the second part of the trip divided by time. Okay, so we know that velocity equals distance divided by time, or velocity equals displacement divided by time. So it should make sense that if I want to find the velocity for the whole trip, I can add the displacements for the whole trip together and then divide that by the total amount of time the trip took, and that will give me the velocity. And in fact, we're already given the distance in both parts of the trip. The first part of the trip, we're told that we go for 100 kilometers. And in the second part of the trip, we're told that we go for 100 kilometers. Okay? But the problem is I don't have the amount of time that it takes for either part of the trip. Okay, and we're going to say that this is actually T1 plus T2. I need to find out how much time the first part of the trip took. I need to find out how much time the second part of the trip took. And that's actually what this problem is all about. Okay, I know what the distance is, or the displacement is. I need to find the amount of time that each part of the trip took so that I can divide that. And it would be easy to think, in just looking at it, I went 50 kilometers per hour for the first 100 kilometers, and I went 100 kilometers per hour for the second 100 kilometers. It would be very, very easy to think, well, why not just average 50 plus 100, divide that by 2, and get 75 kilometers per hour? Problem is, that's not the right answer. Okay, so let's look and see what the right answer is. So for the first part of the trip, we go 50 kilometers per hour for 100 kilometers. So if we create our motion diagram, 0 plus x, and we know that my initial position x0 equals 0 meters, and my final position equals 100 meters. And I'm going to call this x1 here because that's where we will end up, right, at x1 at 100 kilometers. And it should be kilometers, not meters here. So kilometers. And then I know that my velocity for the whole trip is going to equal 50 kilometers per hour. And already you can see that you could divide 100 by 50 and get 2 hours, but we need to show that. We need to prove this. So for the first part of this, we're given that x0 equals 0 kilometers and x1 equals 100 kilometers and v equals 50 kilometers per hour. And I need time, right? I need t1. And I have a formula that will find the velocity for me. Say, well, wait, Marshall, I don't want the velocity, I want the time. Well, it'll still work, right? So I know that velocity equals change in x over t. And so I want to isolate t. I want to put t over here, and I want to divide by v again, right? And so I'm going to end up with t equals delta x over v. And then I can just solve that. Okay, so t1 equals change in position. 100 minus 0 is still going to be 100. So my change in position was 100 kilometers divided by 50 kilometers per hour equals 2 hours. So I know that my first value is 2 hours. Okay, now I don't really need to recreate all of this again. I can just know that I need to do the same thing for T2 as well. And I can say that T2 equals delta x2 divided by that velocity. And I can just come over here and solve T2. I know that I'm going another 100 kilometers, right? So it's just like now I have x1 equals 0 and x2 equals 100 kilometers. Or I could say x1 equals 100 kilometers and x2 equals 200 kilometers if I wanted. But I know that it's 100 kilometers. So I have another 100 kilometers divided by this time by 100 kilometers per hour. And that's going to give me 1 hour. Okay, and so now I have 2 hours plus 1 hour. So 200 divided by 3 is going to end up being 66.7 kilometers per hour. Okay, so our hypothesis was wrong, wasn't it? We thought maybe we could just divide 100 plus 50 by 2 and get 75, when in fact it actually, our average velocity was 66.7 kilometers per hour over the entire trip. Okay, now I don't expect you to have this type of thought process down for a while yet. We'll do more of these multi-part problems to get that burned into your brain, how to approach these. But I just wanted to kind of introduce this one to you to begin with, and get you to see at least how we might start to try and solve these. So this problem is done, and go ahead and go back to the video for the overall presentation and finish that up. Okay, and this is what I want you to put in the worksheet for this problem.